Good morning. I am D. Sengotin, Assistant Professor of Physics, SNS College of Technology, Coimbatore. Today we are going to see about fiber optics. So, how do optical fibers carry the light? So, in this diagram we can see that inner layer is core and then outer surface is cladding. Then light passing through the cladding. As usual, we can see that light passing through the cladding, that is light refraction. In case theta is greater than theta c, light passing through the core, then theta I is less than theta c, light passing through the cladding material. So conditions required for light passing through the fiber optics core material, that is total and reflection. Theta I is greater than theta c, that is incident angle is greater than critical angle, as well as refractive index of core material is greater than cladding material. Then only light is passing through the fiber optic cable. So light entering the fiber within the angular range will undergo total internal reflection. The diagram shows the total internal reflection. So light passing through the fiber optic cable. So we are required to conditions satisfied, that is theta I and N1, N2. This is the main diagram of optical fiber. So we can see that inner layer is core, then cladding, then covering jacket. There are different types of fibers. So fiber optic used for the communication. In case we are deciding to send only one light, that is single mode fiber, that is multiple layer, that is multi-mode fiber. So according to core and cladding materials, we can use to fabricate glass core, glass cladding, or plastic core or plastic cladding, or glass core plastic cladding materials. There are two different types of materials we have basically used for fiber optics, that is glass and plastic materials. Okay, the diagram 1, 2, 3, 4 shows that the internal reflection. So the first condition is all the diagrams satisfied the N1 greater than N2. Then the second one, very important one, that is incident angle and critical angle. The first diagram shows that the incident angle is less than critical angle, so that light reflected other way. Then second diagram shows that the incident angle is equal to critical angle, so that light traveling due to the surface area of the core and cladding interface. Then the third diagram shows that the internal reflection, that is theta I is greater than theta c, so light is traveling through the fiber at internal reflection, that is total internal reflection. So the third diagram shows that the conditions required for light passing through the fiber optic cable. So the first and second light loss due to refraction. Then the main diagram, that is acceptance cone, light acceptance cone, that is light passing into the optical fiber. So theta I equal to incident, then the theta 2, theta 3, the incident and critical angle. Okay, so basically fiber optics, the light passing through the fiber only required for internal reflection. Then there are different types of classification. The first one is material. So basically what type of material used for making fiber optic cable. So first one is glass materials, then second plastic materials. So we can see that core and cladding materials. So in core, basically core materials used for glass, and then second cladding used for plastic, then core is glass, then cladding also glass materials, then core is used for plastic, cladding also used for plastic. There are two different types of materials for using core and cladding interface, making core and cladding materials. Then second one is very important, mode of light propagation. So what type of energy passed, what type of light passed through the optical fiber. The first one is single mode, second one is multi-mode. So single mode fiber, only one light passing through the optical fiber. It is one mode, single mode fabrication, light passing through the optical fiber. So compare the multi-mode, single mode fiber fabrication, that is core layer is very small, that is core diameter is very small. Then multi-mode fiber, we are passing different lights, different energy passing through the fiber. So compare the single mode, multi-mode core diameter is very large. So single mode fiber used for longer communication, then multi-mode used for local area network due to the loss of energy. Then single and multi-mode, we can see that refractive index, that is step index fiber and also crater index fiber. The step index fiber, the refractive index of core and cladding moving with 1 by 1, that is step by step movement. For example, refractive index of core equal to 1.5, refractive index of cladding equal to 1.45, that is step by step movement. But crater index fiber, the refractive index of core and cladding moving with gradually, that is slightly improved or slightly increased or decreased. there are two different types of step index paper, that is single mode step index paper and multi-mode step index paper, and as well as in crater index paper that is only one material is available, that is multi-mode crater index paper. So these are the basically types of optical fiber. So what type of material used for making fiber optic cable, that is inner surface core and outer layer cladding. Then what type of light passing through the fiber optic cable, that is single or multi-mode. Then finally very important one, refractive index, the index of core and cladding materials, that is single and multi-mode. So these diagrams, those that the losses in optical fiber. So basically losses occurred due to the materials and light passing through the optical fiber. That is macroscopically lost energy absorbed or microscopically absorbed due to the absorption and scattering of light energy. Then the bending impurities. So we can see that input is passed to the optical fiber, then output is not reached out of the level, that is due to the fiber optic loss, energy loss due to bending or some other impurities. So dispersion losses, the diagram shows that the input output range for light passing through the fiber, the some amount of energy lost due to dispersion. Then this diagram shows that the change of polarization, then orientation, light sources. So due to some amount of energy lost due to losses. So finally advantages of fiber optic communication. So small size and weight, fire and export safety, allows you to transmit information over long distances. So basically fiber optic communication is very safe. So fiber optics is also used in medical, for example endoscope. So these are the few applications of fiber optics: telecommunications, space applications, then computer applications, medical and military applications. So father of fiber optics, then Narendra Singh Gavani. Okay, thank you so much.